Hello and welcome to my video, lesson 6.3 on combinations. So combinations are similar to permutations, but they do not care about order. And this is pretty much the big distinction in this unit. So permutations, order matters, and combinations, there is no particular order. So this is one of the big difficulties of this unit, is to be able to recognize a question for what it is. So here is a permutation question, which we've seen before in the last couple of videos and lessons. How many ways are there to select a committee consisting of a president, vice president, and secretary? So notice that here there are different positions or different order of the importance of these different positions in the committee. On the other hand, if we look at a combination version of the same sort of question, it asks how many ways are there to select a grad committee subcommittee of 3 students from 10. So here you'll notice these 3 students, the order doesn't matter. So let me try to relate this. In this committee, in the combination subcommittee, every one of the 3 students has equal value. So if I pick Jimmy and Susan and Adita, and all 3 of them are chosen, then it doesn't matter which one I said first, which of those names I said first. They're all equal value. On the other hand, in the permutation question, if I said Jimmy first, that means he's president, and I say Susan second, that's vice president, and then Adita is secretary, that would be order question. Okay, let's take a look at the next one. So permutation question, here it is. There are 10 students in a race if they finish first, second, and third. So how many different ways can they finish first, second, and third? That's obviously order matters, because first place gets gold, and that's a better prize than silver and bronze. So order for sure matters. It's a permutation question. What about a combination version? Well, there are 10 students in a race. The top 3 advance. So in that case, it doesn't matter, because the top 3 advance. It doesn't matter if you're first, second, or third. They all advance to the next round, and then they have a chance again in the next round to beat each other or to lose to each other. And so the order doesn't matter as long as they are in the top 3. So how many ways can the race finish? So you'll see a bunch of different questions in this video where we look at combination questions. So permutations, we already kind of know. You should already have seen the formula NPR, which is n factorial over n minus r factorial. That's our permutation formula. But for combinations, we learn that it's exactly the same thing, except if order doesn't matter, we're removing the order by dividing by an additional r factorial. And we could kind of prove why this is, but it's not really worth a bunch of time to spend on that. You can go ahead and look it up if you're interested. But basically, we're just going to remove that order. So if let's talk about this top 3 situation, right? If I'm just going to go A, B, C for the top 3 students. If they land in the top 3, it doesn't matter the order of those as long as they're top 3. So they could be A, B, C. They could be B, A, C. They could be A, C, B. They could be C, B, A. They could be C, A, B. They could have C in the middle, so it'd be B, C, A. And you can see that there are 6 different options. Well, where is that 6 coming from? It's coming from 3, 2, 1, or 3 factorial, which is 6. So why are we getting rid of that 3 factorial? Well, that's this part. That's this that we're dividing out the order. So whatever number we choose, we divide out that order. Okay, so that's kind of the proof for it. Won't go into, it's not really a proof, but we won't go into more detail. This is also written in your formula sheet. So obviously the formula here is written in your formula sheet. But this part's also written in your formula sheet. You need to be able to recognize either notation on a unit exam or diploma. Both can show up. So just be aware of this like weird brackety thing that could show up as well. And notice that it's the same as the perm formula, but is divided by that r factorial like we just talked about. This is not in your formula sheet, but it is helpful to know about because sometimes a question will say, hey, which of these students has the correct answer? And then it'll show like a bunch of different versions. You should kind of know which ones are correct. There's often going to be many correct, but you get to decide which ones, or you get to hopefully choose the correct ones. Okay, so let's start off with a nice simple one. When making a fruit salad, Mr. Drager has 10 choices of fruit to add, but since Mr. Drager says, Mrs. Drager says I can't just add them all, I can only choose 5. How many different versions of the fruit salad could I make? So in this question, we have 10 items, and we're choosing 5. So literally, we write it like this: 10, choose 5. That's how we say it. That's how we write it. And so, actually, I'll go ahead and maybe just do this. Actually, I'll go ahead and maybe just do this by hand for this first time, and then we can look at more calculator versions in a bit. So this is what it would look like. 10 times 9 times 8 times 7 times 6 times 5 factorial. The other one is, I'm going to go like this: 5, 4, 3, 2, 1 times 5 factorial. And so I'm going to divide out the two 5 factorials. Those cancel. The 3 and the 2 can cancel with the 6. I can divide the 5 and the 10 to get a 2. But I'm also going to simplify with the 4. So I'm going to get 9 times 4 times 7 at the end of the day, which is 63 times 4, which is 12, and then 24. So 2252, I believe. Yeah, 252. And so there is our final answer. So being able to do this in your head is wonderful, but I'll be honest, like most of the time we're just going to use our calculator. Okay, so let's take a look at another one. This one is a bit more complicated. We've got a couple more steps happening here. When going to Blaze Pizza, hashtag not sponsored, Mr. Drager likes to take everything on his pizza, but for some reason people don't like this. They frown on this and they think that that's embarrassing. So most people only choose 3 types of cheese out of 8, 2 types of meat out of 7, 4 types of veggies out of 9. So I've just made up these numbers, but whatever. Let's just pretend this is what most people choose. How many variations of pizza can be made like this? So what we have to really think about is this word here, and actually there's an invisible and right here. So what it's saying is most people choose, so 3 out of 8. So we're going to go 8, choose 3. And 7, choose 2. And 9, choose 4. So in total, we've got this big old expression. And we're going to go ahead and find our answer. Alpha window down to number 8 lets us put in one of our options, this one. And we get an answer of 148,176. So although it might seem like a complicated question, we just have to read carefully and sometimes even read between the lines with like an and, for example. Okay, so oftentimes we're going to see questions that are, I'm going to call them card questions, where we're going to draw cards from a deck of cards. Now, you don't have to memorize what a deck of cards looks like, but here's a picture of one. I think from the 30-2 textbook, I believe is where I took this from. But anyways, this is a standard deck of cards of 52 cards. And so then we have to ask how many hands have all hearts for a game of poker, which uses 5 cards in a hand. Okay, so what we're trying to do is just figure out the number of hands with all hearts. Okay, so what we know is that there are 13 hearts in the deck, and we're choosing 5 of them. So literally, this is all we're going to do. 13. Oh, now I'm going to do it the other way. 13, choose 5, and so we get 1,287 hands that have all hearts. We're going to have a bunch of different examples here, so go ahead and pause the video now, try each of these out, and see if you can get the same answer I do. All right, so how many hands have a flush? So all the same suit. So now what we need to realize is that it's all hearts is one situation, which is 13, choose 5. Or, which means we add all diamonds, or all clubs, or all spades. And so because we said or, we add in between. Another way we could write it is 4 times and then 13, choose 5. They're both perfectly reasonable ways of writing this out. We're just going to use the answer we had from before. And so we get 5,148. All right. Let's take a look at the next one. How many hands have at least 3 kings? So this is an interesting sort of question. When we see this at least, this is an important statement. So that means we could have 3 kings or 4 kings in a hand. Either one is okay. So what we're going to do is we're going to say, what if we have 4, choose 3, and the rest of the hand is going to be made up of other cards. So we're going to say 48, 48, choose 2. That does not look very pretty. So any other card in the deck could make up the rest of the hand. So 4, choose 3, 48, choose 2. Or, like I said before, which means adding 4, choose 4. So now we're choosing all 4 kings and 1 other card out of the 48 total. So now we have these 2 things that we're going to add together. It takes some time to write these in, but other than that, it's pretty simple. All right, as you can see, my calculator shows exactly what I wrote on the page. And so we multiply it and add in whatever, 4,560. So that word at least was doing some important heavy lifting there. Okay, let's try the next one. How many hands have a royal flush, meaning all the same suit, and specifically the 10, jack, queen, king, and ace of that suit? Oh boy. So there's going to be some interesting versions of this or ways of reading this, but I'm just going to say, like, sometimes the question might just be easier just to like think it through. This one's probably not going to be a good diploma question, but I just wanted to throw it out there. If we look at the deck of cards, how many hands have a royal flush? Well, you could have a royal flush in diamonds, sorry. This is the ace over here. It's on this side, I know, but whatever. I'm just going to go like that. Or we could have it with hearts, or with spades, or with clubs. And so it's an or statement in between. So it's 1 plus 1 plus 1 plus 1. It's simply 4. That's literally all I'm going to do for that question. Okay, let's read this next one. One more. It says, how many hands have at most 2 aces? So now we have to think about this, and we have to say at most. So how many aces could we have? We could have 2 aces, which means we would write 4 choose 2 times 48 choose 3, or, which means adding, 1 ace, which means it's 4 choose 1 times 48 choose 3, 4, sorry, choose 4. Or, and this is one people miss a lot, 0 aces. So you could write 4 choose 0. I won't do that in the calculator because it just means 1. And since it's a times anyway, 1 times anything doesn't matter. So 48 choose 5. Plus, and like I said, I'm not going to write in the 4 choose 0 because it just takes time when it actually doesn't speed anything up or make anything better. I'm just going to plug that in, and I get 259. 4400. So it's 2 million whatever options, different hands. Now, all this is interesting, but it doesn't really tell us a lot about probability. And honestly, this unit's not about probability, but I like to think about probability to make these questions kind of actually useful. So if you're not worried about the diploma, this will not be on the diploma. But what we want to do to find a probability is we really want to divide the favorable over the total number of options. So if we're saying I want to have at least 3 kings, well, my favorable will be the 4, 5, 6, 0, which is what we already calculated. And then the total will be 52 choose 5. So that will always be my total because it's the total number of options for a deck of cards. So if you're curious, it would look like this. That number there is the total number of cards. So turns out actually that many hands will have an ace in it. You're pretty likely to have at least 1 ace when at most 2 aces. How do I word that properly? So most hands will not have 3 or 4 aces. That's really what this last number means, the number in red. Most hands will not have 3 or 4 aces. Okay, anyways, it's kind of an interesting little quirk there. And that's how these questions are actually useful, is probability. Okay, let's go ahead and continue on. We're almost done the lesson, the video. We've got 2 more questions left. The handshake question. So this is going to be the first version of it. How many handshakes occurred in a room of 32 people if every single person needs to shake hands with every other person in the room? Well, let's simplify this and just first ask, what if there were only 2 people? Well, if there's 2 people, right, then both shake hands, which means there was 1 handshake that occurred. If there were 3 people, then there would have been a handshake that occurred like that. And so there were 3 handshakes that occurred. So if there were 4 people, we're going to start to get more complicated here pretty quickly. There's 1, 2, 3, 4, 5, 6 handshakes that occurred. If there were 5 people, it goes all the way around the outside. So there are 5 6, 7, 8, 9, 10. Okay, now you may or may not notice this as a pattern, but I'm going to show you that this actually is a pattern. Every time people shake hands, how many people are we choosing to shake hands? Well, we're choosing 2 people. And if there's 2 people to choose from, it's 2 choose 2, so it's 1. And if there's 3 people to choose from, it's 3 choose 2, it's 3. If there's 4 people to choose from, it's 4 choose 2, it's 6. 5 choose 2, it's 10. We could double check this if you don't quite believe me. I'm just going to do 4 choose 2, and I'm going to do it again, but for 5. The other ones are probably easy enough that you can check them really quickly in your head, but there they have it. So there's a pattern that's happening here. So the pattern that I'm trying to point out is that if we go like n, it's the total number of people okay, choose 2, because 2 people, it takes 2 people to shake hands. And it equals the number of handshakes. So I'm going to tell you this, if you come across a question where it seems too difficult to you to do the question, break it down, do a simpler example, and see if you can figure out the pattern that's happening. That's how you solve these. So if there's a room of 32 people, that means it's 32 choose 2. That's how we solve this. And just because we're kind of close to the right numbers or whatever, let's go ahead and think about this as a like actually write it out, you know, with the actual formula. So if we do that here, we can see that this is going to be 32 times 31 times 30 factorial over 2 factorial 30 factorial. You can see that the 30 and 30 cancel. The 2 factorial simplifies with the 32. And so it's 16 times 31. Now, even that is kind of difficult to do in our heads. So let's pull out our calculator. 496. You could do it in your head because, you know your elementary, but let's just pull out the calculator. Okay, so hopefully that helps you understand the handshake questions a little bit better. We're going to do one more question, and this is going to relate directly to our next video. How many ways can a committee be made from a total of 9 students if the committee needs to have 6 members? Well, it's simple. 9 choose 6. That seems simple. It is simple. But I want to say this in the reversed sort of way. Well, if I'm choosing 6 people to make up the members, then I'm also choosing 3 people to not be members. And so both of these should be the same answer. 9 choose 6 and 9 choose 3. Bingo. They're both the same answer. And so this is going to make a big difference for our next video, which is about Pascal's triangle. I hope this video helped you better understand some combination questions, some common ones, as well as combinations in general, and how these are about order not making a difference, not mattering for these questions. I hope the video helped, and good luck.